designed to assist the Polaris snowmobile technician with service procedures on the 1992 500 Indy Special. Major topics include setup adjustments on the EFI system with related information. We encourage all technicians to spend some time viewing this video and also refer to it from time to time for technical assistance. The first and one of the most important steps in preparing an EFI system machine is the proper preparation of the battery. The charge rate and fully charged specific gravity and voltage readings are shown at room temperature. Install a dial indicator into a spark plug hole and locate one piston at top dead center. Rotate the flywheel to the correct before top dead center specification. Then note and make a reference point on the flywheel for the running timing check. Some of the areas which have been reported as problems during setup are directed towards the main connector at the headlight pod. We have had instances where the plug color codes do not match when plugged together. Mismatched plugs result in indicator malfunctions. Please refer to your Master Repair Manual wiring diagrams for wire colors and plug locations. We have received a few calls regarding the identification of connectors. Shown here is the master fuse link. This must be unplugged during battery charging or during extended periods of machine storage. The Polaris Fuji harness connector wiring can be verified as correct by referring to the numbered terminal halves at each wire. These are shown on the wiring diagram in the body electrical section of the Master Repair Manual. This information and where to find it will be a great help when troubleshooting electrical wiring problems. Also, remember to use Polaris anti-corrosion lubricant on all connections. The fuel pump wiring connector must have a tie strap placed around it to prevent its separation during machine operating. Refer to Service Bulletin S9202 for complete information. We will now proceed with the throttle position sensor adjustment. The first step is to back out the idle stop screw until it is non-effective. Next, unhook the throttle cable from the throttle flipper. Snap the cable a few times to ensure the throttle butterflies are completely closed prior to adjusting the sensor. The throttle position sensor is located on the magneto side throttle body. It is adjusted by loosening the two attaching screws slightly and rotating it in the direction required according to the select monitor display reading. Hook up your select monitor to the machine and enter F14, noting the degree reading. The correct reading is 0.1 degree as shown. Any other reading will require the adjustment of the throttle position sensor as previously discussed. After the throttle position sensor has been adjusted with the butterflies closed, it will be necessary to make an initial adjustment of the idle stop screw to permit engine starting. With the select monitor on F14, turn the idle screw clockwise until a display reading of 3.5 degrees is shown. Further adjustment of the idle screw may be required to obtain the recommended engine idle speed of 1600 RPM. Advance the select monitor to F21. Remove the rubber access plug from the electronic control unit and adjust the MR screw to the proper setting as shown in the Master Repair Manual. MR adjustment table of Section 4. When initially fueling the machine, it must be noted that the fuel tank is quite long, and approximately 5 gallons of fuel need to be installed to allow the pickup line to be submersed when the unit is placed on a jack stand. Otherwise, purging the fuel system of air cannot be complete. Connect the black and gray dealer mode wires together on the Select Monitor service harness. Fuel pump activation. Next, turn the ignition switch full right to activate the fuel pump. Listen to the pump. It will cycle 3 times and shut off. Then shut the key off and disconnect and reconnect the master fuse link. Repeat this procedure 3 times to completely purge the fuel system of air. Fuel pressure gauge installation and rail pressure test. Install the fuel pressure gauge line and T on the inlet side of the fuel rail. Connect the main line to the opposite side of the T as shown. Cycle the fuel pump while noting the gauge pressure. The fuel pressure with the pump running should be between 35 to 37 psi. After the pump stops, the pressure should maintain a pressure of 35 psi for approximately 1 minute, then slowly fall. This is acceptable. In the event that fuel pressure drops rapidly after the pump stops, the pressure regulator should be tested. This is accomplished by squeezing the return hose to the fuel tank with the pump running while observing the gauge. The pressure should rise and return to normal as the hose is released. If pressure does not hold, the regulator should be changed. Additional important factors which affect engine starting, idle RPM, and throttle response are belt to sheave clearance and belt tension. The correct belt to sheave clearance is 20 thousandths of an inch or as close as possible without dragging on the belt. The correct belt tension is 1 1/4 inches at full neutral. Refer to the Torque-O-Matic drive section of the Master Repair Manual for specific operation. Dealers should also note that a revision of the 9,000 to 12,000 foot drive clutch setup recommendation, please change your charts to read A 10M red shift weight bushed with a blue spring. The complexity of today's high-performance two-stroke snowmobile engines require high-quality fuel that is matched to the surrounding climate and temperature conditions. For example, gasolines for winter are more volatile and faster vaporizing to provide easy cold starts. Volatility is reduced in warm months to minimize the tendency to vapor lock. Volatility is also changed for geographic areas such as lower volatility in the south, where higher temperatures prevail. Fuels are blended to meet seasonal and local needs. For winter, a greater portion of fuel components are the fast vaporizing type. For summer use, more of the fuel components are the slower vaporizing type. While these seasonal and geographic changes in standards for volatility minimize problems, they do not completely eliminate them. For example, during the fall, a gasoline volatility for higher summer temperatures may experience problems due to unseasonably cold weather. Because of these factors, Polaris has introduced a new electronic enrichment kit, which will enrich the fuel mixture for cold weather starting. This kit is presently available for the 500 EFI SP Indy. This completes our brief presentation on Polaris service topics. We sincerely hope you will benefit and continue to improve in providing our customers with the best of what we call Polaris quality service.